Hello everyone. Today I will show the solutions to the Prairie Math League High School Round 124 Problems 5 and 6. For problem 5, we're given an increasing sequence of positive integers a sub 1, a sub 2, and a sub 3 that has a property that suspiciously looks like the Fibonacci sequence recurrence relation. So we can solve this by assuming that, or letting variables x and y be a1 and a2 respectively, as shown here. Then we can make a table of what a1, a2, and so on are defined on based on x and y. So for instance, here, a1 is x, a2 is y, a3 is x plus y, a4 is x plus 2y, a5 is 2x plus 3y, and we can continue this. And we eventually see our important results, namely that a sub 7 is equal to 5x plus 8y, and a sub 8 is equal to 8x plus 13y. Now I continue our solution here. And now this is basically a Diophantine equation where the restrictions are that x and y are both positive integers with x less than y. X is less than y because the sequence is increasing. So we get a few possible solutions, but we can narrow these down. This and this are 0, so these don't count. And here, this is greater than this. But this would imply that a1 is greater than a2, so this also doesn't count. So this only gives us one solution, which is x equals 8 and y equals 10. Hence, we see that a sub 8 is equal to 8 times x plus 13 times y, which is 8 times 8 plus 30 times 10, which is 194. So the answer is D. Now for problem number 6. This is quite an interesting problem. And basically, you start here every day on a path, and you want to get to here. Now, half the time, you can just walk the 2 miles, or 2 miles. You can walk this, but the other half of the time, there's like this invisible barrier by this troll. And no, you're not allowed to fight the troll. So now, there's quite a few ways to solve this, but since we don't know where the barrier is, we have to think of like the optimal strategy. Now, one strategy would be to walk, hang on, let me clear this out, to walk this distance, and if there is no troll, then we can walk through, but if there is a troll, then we have to spend a lot of time walking this distance, and this gets a value that is suboptimal. We can do better. Now, the other extreme will be to go here every day and be paranoid of the troll. So no matter what, you're following this path every day. And if there was no troll, then you've just wasted, like, a lot. So, yeah, we don't want this either. So our trick here is going to be to select a point that we walk to in the middle. Let's say here. Then either we walk, if there is no troll, then we can walk directly here. And if there is a troll, then we can just walk here. And hopefully in both cases, we can see that we've reduced some amount. And we'll see that this is true by the end. So let this distance be x. And we can now use this diagram here. So this is x. And as you can see, I've already labeled some side lanes here. So let E of D be the expected distance. Then we can see that we have to walk this part first. Then either we can go, either there's no troll and we walk this part, or there is a troll and we can walk this part. And just sum the corresponding lengths. And note the 1/2 here because of the expected value, average. And we get this expression here, which can be quite hard to summarize, or minimize. So right now we just let this be equal to y. Then 9x squared plus 9 is equal to x squared plus 2x plus y. So here we've just moved x to the other, moved x to the other side, and squared both sides. Then we can simplify. And, what was it called? Sorry, I forgot the name. But anyways, I should remember this later. Oh yeah, completing the square. Anyways, so yeah, we know that this is at least 0 because it's a square. So we can substitute this in, and we get that y is greater than or equal to 2 square root of 2. Now this is minimized when x is equal to 1 over 8y, as we can see over here. And yeah, we can use a calculator to make sure that this actually can be attained. So, and we do see that it is possible. So here we have this back into this expression for this value, and we get our final answer of 2.621, or C. Alright, so here's another solution for problem number 6, and this is the one that I actually used in the contest. So, we can actually use, as you can see here, calculus. So as before, we see that the expected distance is equal to this expression here. Now we can take the derivative with respect to x, and we can use the chain rule for this expression to get this. The derivative of negative x is just -1, and this constant stays here. And after simplifying a bit, we see that x is equal to square root of 2 over 4. And we can take the second derivative, which I haven't shown here, but this verifies our solution. And we can see that the minimum expected distance is equal to 2.6213 again. And this is C. Thank you for watching.